All right, today we're doing volume of prisms and cylinders. Now, the reason they group these two things together is because they have two bases. So first let's talk about volume. Basically, how I view volume is it's all the space inside a solid. At least it is for us, okay? All the space inside a solid. So if you had like, I don't know, a carton, those round cartons of oatmeal or whatever, like those, all the space inside of there would be the volume. So the first one we're going to talk about is a prism, which looks just like this. Okay, now a prism could have a rectangle on the bottom, a prism could have a triangle on the bottom, it could have a pentagon on the bottom, it could have all kinds of things on the bottom. So we're going to focus on a couple different kinds. We won't get as crazy as doing like a pentagon, but we'll do some of the basics here today. Now, how you find the volume is it's the area of the base times the height. And how they're going to do this, or how I do this in class, I just say big B times H. Because big B for me means area of the base. So you always have to find the area of the base, then you can multiply it times the height, and you're done. You have volume. And since we're dealing with 3 dimensions here, it's going to be units cubed. Units cubed, so 3 dimensions, units cubed. So let's go ahead and look at number 1 to begin with here. Find the area of the base and the volume of each figure below. So first let's talk about the area of the base of this prism right here. And what is the base? Think about it. The base has to be parallel to the other base. That sounds kind of weird. So a base is a face and they're parallel to each other, just like these 2 triangles are. Nothing else in this prism is parallel to another side, just these 2 triangles. So let's focus right here on this triangle for our base. And the formula for the area of a triangle is 0.5 BH. Okay? Now, the base and the height of just the triangle, we're only looking at this triangle right here. And height is always perpendicular to the base. Perpendicular. Look at the picture. Do you see the perpendicular right here, the 90-degree angle? So that must mean my 12 and my 5 are my base and my height. So B equals 0.5 times 12 times 5. And when we type that all into the calculator, we end up getting 30 meters squared. So now that we have the area of the base, we can focus on finding the volume. And the volume is area of the base times the height of the prism. So the volume would equal, the area of our base is 30, and the height of our prism is right here. It's going to be 9. And then on your calculator, 30 times 9 is going to give you 270. And remember our units. We're dealing with volume now, so it's going to be meters cubed. Okay? So area of the base, and then multiply it times the height, and you have the volume of your prism. I'm going to ask that you do number 2 for class, so bring number 2 totally done to class, and we will discuss it then. So I'm going to move down here to number 3. Okay, there are 2 prisms here, so you're going to have to find the volume of each one separately. So let's talk about this one here first. Now I can see this base right here, and I can see that this part's 4, but I need to know what this part is right here. And if you look on the other side, there's a 2. So this right here must be a 2. So the area of this base then would be 2 times 4, and 2 times 4 gives you 8. So we're done with the area of that base. But they want volume. And volume is the area of the base times the height. What's the area of our base? 8. We just found it. Now what's the height of this prism? It's going to be 9. So then 8 times 9, when you type it into your calculator, is going to give you 72. And this is going to be inches cubed because it's volume. But you're not done. So let's go ahead and talk about the second prism right here. Now I can see this base here on top, but I'm not real sure what the dimensions are. So let's think about where we can find this dimension and look straight across on the other side. And you should see that this side is 6. How about this dimension right here? Well, go across this way and I see nothing, but then go up this way and I see a 4. So this must be 4, which means this must be 4. So then the area of our base here is going to be 6 times 4, which is 24 inches squared. Now we're going to find volume, which is area of the base times the height. The area of our base we just found was 24. And the height is right here, 3 inches tall. So then 24 times 3 on the calculator is also 72. It's kind of weird. They're both the same, huh? And we want to combine these together. So this L-shaped figure right here, we want to add these together. Add these together right here, and you will get 72 plus 72. And when you add that together, you get 144, not that, there we go, 144 inches cubed, just like that. All right, so just make sure that you add everything together. All right, now that we got that, let's keep going. What could be next? Oh, some words here for you. A cube has a side length of 4 centimeters. Find the volume of the cube. Well, let's think about a cube. A cube has all the same proportions. Now, my drawings are not usually the best, but I do the best I can. So you just do the best you can. So something like that looks like the cube. And if you need to pause it and draw it, you go ahead and do that. That's fine. And a cube has all the same dimensions. So this would be 4, this would be 4, and this would be 4. So it says find the volume. So first we have to find the area of this base. And the area of that base would be 4 by 4. So B would equal 4 times 4, which is 16. Then to find the volume, it's area of the base times the height. And we just found the area of the base, which was 16. So volume equals 16 times, and then the height of this cube would be 4. When you multiply these together, you get 64 centimeters, and this is volume. So cube it. So draw the picture as best as you can. I know not everybody's will look perfect, but just do the best you can with it, okay? Let's talk about the volume of a cylinder. Now it's in this section because a cylinder is like a prism, except it's got round surfaces, right? It has 2 bases, just like a prism. So miraculously, the volume is still area of the base times the height. The only thing that has changed here is we have a circle, but like you can handle that, right? Because like look up here. We had a triangle. Here we have a rectangle. Now we have a circle. So the base is just changing all the time, but the formula is remaining the same. So let's move down here to number 1. It says find the area of the base and the volume of each figure and round the answer to the nearest whole number. Well, the first thing I'm noticing is this right here is my diameter, right? And we probably are going to need radius. So the radius is 5 meters because it's half of the diameter. So first find the area of the base. Pi r squared. Pi is 3.14. We get to round to the nearest whole number, so we get to write 3.14 for our pi. And our radius, I just talked about it, is 5. So 5 squared. The next thing you want to do is work out 5 squared. And 5 squared is going to be 25. So 3.14 times 25. Then we multiplied that together into the calculator, and I got 78.5. Now, if you're rounding to the nearest whole number, 78.5 is going to round, and that means approximate, those little squigglies, to 79. Well, we've only found the area of the base, right? And they want you to find the volume. Volume is area of the base times the height. So our volume here, our base is going to be 79, and the height of our entire cylinder right here is 32. Some bigger numbers. 79 times 32, when I typed it into my calculator, was 2,528 meters cubed. All right, so what I'm going to have you guys do is do 2 and bring that to class. So just finish up number 2. It's a little bit easier than number 1, and bring that to class with you, and I will discuss it when you come in. We do need to talk about this guy though, right? So let's talk about what this actually is. If you can imagine a toilet paper roll. I know that that's not the prettiest thing to imagine, but imagine a toilet paper roll. And that's what's going on here. So we have this big cylinder, and they have punched out the cylinder in the middle. So they've got big cylinder minus small cylinder in the middle. There we go. So first let's focus on the big cylinder. And in the big cylinder, I'm going to use the blue for the big cylinder. We have this, and that's our radius. Okay? So if we have to find the area of the base, it is a circle. So pi r squared. We're going to be rounding to the nearest whole number. So this would be 3.14 times 18 squared. Then we work out what 18 squared is in the calculator. So we have 3.14 times 324. And when I multiply those into the calculator, I end up getting 1017.36. 1017.36. But we're going to round to the nearest whole number. So that's going to be approximately 1017. We still got to find volume, right? We've only found the area of the base. So volume is area of the base times the height. The area of the base is 1017. And the height of this, I'm just going to call it a toilet paper roll, is 12. So 1017 times 12 is 12204. Okay? So let's talk about the small cylinder. The small cylinder is right here. I'm going to take care of this one in green. And it has a radius of 9, and we're punching that out. We're subtracting that cylinder out. So first, let's calculate the area of our base. So the base is pi r squared, and we get to round to the nearest whole number. So we get to use 3.14 for the pi. So 3.14 times 9 squared. Then we work out 9 squared, and 9 squared is 81. So 3.14 times 81. Then we type 3.14 times 81 into the calculator, and we end up getting 254.34. And we have to round this to the nearest whole number. So this base is going to be approximately 254. But we've only found the area of the base. We still have to find the volume. And the volume is the area of the base times the height. The area of my base is 254. And my height of the toilet paper roll is 12. So 254 times 12 gives me 3,048, like that. And we're going to subtract these two numbers. So when I subtract these two numbers right here, I end up getting that the volume of the toilet paper roll, which, by the way, I keep saying toilet paper roll because I'm going to be checking to see if you've listened to this video. So make sure you know that looks like a toilet paper roll when you come to class. Is going to be 9,156 inches cubed because it's volume. Okay? So make sure you finish up those other two problems. If you need to review anything I've done, go back and re-watch it and re-listen. And I will see you in class. Have a good one.